What if I told you that right now, in this very moment, there could be millions of other versions of you watching different versions of this video? And what if quantum computers are the key to proving it? Google just made a claim that shook the scientific world. Their new quantum chip called Willow might be borrowing computational power from parallel universes. This isn't science fiction anymore. Think about this for a second. A calculation that would take the world's fastest supercomputer 10 septillion years, that's a 10 with 25 zeros after it. Willow did it in under 5 minutes. Astonished, that's longer than the universe has existed. In fact, it's trillions of times longer. So where is this computational power coming from? Some scientists say other universes. Hartmut Navin, the founder of Google Quantum AI, dropped this bombshell. This lends credence to the notion that quantum computation occurs in many parallel universes. But is this real science or just hype? Today we're diving deep into the quantum rabbit hole where artificial intelligence meets the multiverse. We'll explore cutting-edge quantum AI, the mind-bending many worlds theory, and why some scientists think we're on the verge of the biggest discovery in human history. But here's what's really wild. This isn't just about proving parallel universes exist. It's about what we could do with that knowledge. Imagine solving problems by literally accessing infinite computational worlds. Interested? Before you think this is all science fiction, consider this. As of 2025, there are about 1,000 quantum computers worldwide, with major tech giants investing billions. Something big is happening, and it's happening fast. Let's start with the basics. Quantum AI combines two revolutionary technologies, quantum computing and artificial intelligence. But to understand why this matters for the multiverse, we need to grasp what makes quantum computers so special. In classical computers, information exists as bits, either 0 or 1. But quantum computers use qubits, which can be 0, 1, or both simultaneously. This is called superposition, and it's where things get weird. Imagine flipping a coin that lands both heads and tails at the same time. That's essentially what qubits do. They exist in multiple states until we observe them, then they choose one reality. But here's where it gets even stranger. Qubits can become entangled, meaning they're mysteriously connected. Change one, and its partner instantly responds, even if they're on opposite sides of the universe. This gives quantum computers an almost magical ability. While your laptop checks solutions one by one, a quantum computer explores millions of possibilities simultaneously. It's like having an army of computers working in parallel dimensions. Now AI enters the picture. Artificial intelligence is already revolutionizing how we solve problems, but it's limited by classical computing power. Quantum AI removes those limits entirely. Interested in drug discovery, quantum AI could simulate complex molecular interactions that would take classical computers centuries. We're talking about finding cures for diseases we thought were incurable. Financial markets, quantum AI analyzes countless variables simultaneously, predicting trends with unprecedented accuracy. It's like having a crystal ball powered by the laws of physics. But AI isn't just benefiting from quantum computing, it's making quantum computers work better. Machine learning algorithms are solving one of quantum computing's biggest problems, errors. You see, qubits are incredibly fragile. The slightest disturbance can ruin a calculation. But AI algorithms are learning to predict and correct these errors in real time, making quantum computers more reliable than ever. Google's latest breakthrough with the Willow chip reduced errors below what they call the magical threshold. This means for the first time, adding more qubits actually makes the system more stable, not less. Investment in quantum technology hit $2 billion in 2024 alone, a 50% jump from the previous year. Major players like IBM, Microsoft, and Google are racing to achieve quantum supremacy. Interested? Now let's talk about the many worlds interpretation, the theory that suggests every quantum event creates parallel universes. This isn't New Age mysticism, it's a serious scientific theory proposed by physicist Hugh Everett in 1957. Traditional quantum mechanics says that observing a quantum system collapses it into one state. But Everett asked, what if it doesn't collapse at all? What if all possibilities happen, just in different universes? Think of it like this. Every time you make a decision, the universe splits. In one branch, you chose coffee. In another, you chose tea. Both versions of you exist, living out the consequences of that choice. According to many worlds, there's no special collapse of possibilities. The universe just keeps branching, creating an ever-growing tree of parallel realities, and we only experience one branch of that infinite tree. This sounds crazy, but it actually solves major problems in quantum physics. Remember that spooky action at a distance Einstein worried about? In many worlds, there's no spooky action, just different branches of reality. Interested? The famous Schrödinger's cat thought experiment makes more sense too. The cat isn't both alive and dead in one universe. It's alive in some branches and dead in others. We just don't know which branch we're in until we look. But how does this connect to quantum computers? Well, when a quantum computer processes information in superposition, many worlds suggests it's literally computing across parallel universes. Each calculation happens in a different branch of reality. David Deutsch, a quantum computing pioneer, takes this seriously. He argues that quantum computers work because they access computational resources from parallel universes. Without the multiverse, their power makes no sense. Think about Shor's algorithm, which can factor huge numbers exponentially faster than any classical method. Where does this speed come from? Deutsch says parallel universes doing the work simultaneously. Amazed, this brings us back to Google's Willow chip. When it solved that problem in 5 minutes that would take classical computers 10 septillion years, was it really borrowing computational power from other universes? The random circuit sampling benchmark Willow performed is specifically designed to be quantum advantageous. It's a problem that showcases quantum parallelism at its most extreme. Interested, but here's where the debate heats up. Critics say this is just marketing hype. The calculation Willow performed has no practical use. It's like claiming you're the world's fastest runner on a track only you can access. Theoretical chemist Neil Shenvi called these multiverse claims overblown and sensationalistic. He points out that quantum effects don't require parallel universes. Other interpretations work just as well. The Copenhagen interpretation, for instance, says quantum systems simply exist in undefined states until measured. No parallel universe is needed, just fundamental uncertainty in nature. There's also pilot wave theory, which says particles have definite positions guided by invisible waves. And objective collapse theories suggest quantum systems spontaneously choose states based on physical triggers. The fundamental problem: all these interpretations make the same predictions. They're different stories about what's really happening, but they give identical experimental results. Interested, this is why the multiverse debate is so contentious. If we can't experimentally distinguish between interpretations, is believing in parallel universes science or philosophy? But proponents like physicist Lev Weidman argue many worlds is the only interpretation that preserves locality, the principle that objects are only influenced by their immediate surroundings. Weidman's 2024 paper shows how many worlds avoids action at a distance in quantum experiments. In his view, this makes it the most scientifically consistent interpretation. Some scientists speculate that future quantum computers might actually test many worlds. If we can maintain quantum coherence in large enough systems, we might see signatures of parallel branches. Imagine an experiment where a conscious AI runs on a quantum computer in superposition. Would it experience multiple realities simultaneously? This could be the key to proving many worlds. Interested? Already, AI is designing quantum experiments humans never imagined. It simplified achieving quantum entanglement and discovered new quantum optics setups. What if AI finds a way to peek into parallel universes? The philosophical implications are staggering. If many worlds is true, every possible version of your life exists somewhere. Free will becomes choosing which branch to experience, not creating new outcomes. Some even speculate about quantum immortality, the idea that you always survive in some branch of the multiverse. It's a disturbing thought that challenges our deepest beliefs about life and death. But let's get practical. Even if the multiverse isn't real, quantum AI is transforming our world right now. By 2035, quantum technology could generate $97 billion in revenue worldwide. Quantum and sensors are detecting gravitational waves and dark matter. Quantum communication promises unhackable networks. And quantum computers are solving optimization problems that improve everything from traffic flow to drug delivery. Interested, IonQ and University of Washington used quantum computers to simulate neutrinoless double beta decay, a physics process that could reveal why our universe has more matter than antimatter. Amazed, Google AI's analysis of the double-slit experiment found patterns suggesting permeable boundaries between quantum possibilities. They're literally finding cracks in the fabric of reality. Curious, the truth is, we're at an inflection point. Quantum AI is advancing so fast that yesterday's impossibilities are today's breakthroughs. Who knows what we'll discover tomorrow? Whether or not parallel universes exist, quantum AI is expanding the boundaries of computation itself. We're entering an era where the line between science fiction and science fact is blurring daily. Critics are right to demand evidence. Extraordinary claims require extraordinary proof, but dismissing quantum multiverse connections entirely might cause us to miss the biggest discovery in human history. As more quantum computers come online and AI gets better at controlling them, we'll probe deeper into quantum reality than ever before. The answers we find might challenge everything we thought we knew. So here's the million-dollar question. Are we alone in our universe, or are infinite versions of us exploring infinite possibilities? Quantum AI might finally give us the answer. The convergence of quantum computing and AI isn't just about faster calculations or better algorithms. It's about understanding the fundamental nature of reality itself. Interested? Imagine a future where we can simulate entire universes, explore parallel timelines, or even communicate across dimensional boundaries. Sounds impossible? So did smartphones to people in the 1950s. One thing's certain, the quantum revolution is here, and it's accelerating. Every breakthrough brings new questions, new possibilities, and new glimpses into the strange, beautiful complexity of our universe, or multiverse. Whether you believe in parallel universes or think it's all hype, you can't deny the excitement. We're living through one of the most profound technological leaps in human history. The next time you make a choice, big or small, consider this. Somewhere in the quantum multiverse, another you might be choosing differently. And quantum computers might be the bridge between your world and theirs. As quantum AI continues to evolve, who knows what impossibilities will become commonplace? The only limit might be our imagination, and perhaps the laws of physics themselves. Enthusiastic, what do you think? Are quantum computers really accessing parallel universes, or is this just clever marketing? Let us know in the comments below. We'd love to hear your thoughts on this mind-bending topic. If you enjoyed this journey through quantum reality, make sure to hit that like button. It really helps us create more content exploring the fascinating frontiers of science and technology. And don't forget to subscribe and ring the notification bell. The quantum revolution is unfolding fast, and you won't want to miss our next deep dive into the mysteries of the universe. Thanks for joining us on this exploration of quantum AI and the multiverse. Until next time, keep questioning reality, because the truth is stranger than fiction. Remember, whether we live in one universe or infinite ones, this moment, right here, right now, is the one that matters. Make it count.